meta-analysis in Stata when the outcome is binary and the estimated effect size is an odds ratio. Meta-analysis will be performed to generate a forest plot and funnel plot. So what is meta-analysis? Meta-analysis is a statistical method that is performed or carried out to combine and summarize results from several multiple independent studies that address a specific question or investigate the same scientific question. The meta-analysis will provide an overall estimate of the effect size for specific intervention or exposure compared to control or a reference by pooling results of multiple studies. Those studies investigate the same research question. So the meta-analysis will measure the variability and inconsistency among the studies results by performing a heterogeneity test, and that test will examine and test the degree of variability or inconsistency of the results from these multiple studies by generating a p-value and an I-squared. An I-squared is expressed in percentage, and an I-squared value of 0 indicates no heterogeneity, and an I-squared value of 100% indicates a maximum heterogeneity. The meta-analysis would generate a forest plot. So what is a forest plot? Forest plot is a graph that displays the results from the meta-analysis and produce a summary. So it does summarize the effect size estimate for each individual studies and the pooled or overall the effect size, and also produce a 95% confidence interval and percentage of weights. And there are 3 parts or sections in the forest plot. The first part is descriptive statistics, showing the ID for each study, the author name, the year of the study, the sample size, the 95% confidence interval, and another part which is a diagrammatic representation of the effect size and the confidence interval, and a third part which shows the overall statistical analysis output of the estimate size and the heterogeneity test among studies. Meta-analysis also will produce a funnel plot. A funnel plot is a graphical display of estimate effect size plotted against the standard error or a sample size. So funnel plot is a scatter plot with y-axis, have on it a standard error, and x-axis is the estimate size for each individual study. So the funnel is generated to assess whether there is a publication bias. Here in this Stata data view, I had placed 12 studies taken from literature for 12 publications that addresses or investigate a specific or the same scientific question. So in each study, individuals were recruited into the study and the participants were segregated into 2 groups control group and treatment group or intervention group. And the treatment group were given a drug and followed up to see whether the condition is treated, and a control group which is also being given a placebo or no treatment, and the condition were observed whether the condition has been reverted back to normal or the individual recovered. So here from these variables or small data set, it shows there are a variable for study ID from study 1 to study 12, and then the sectioning of the intervention group, which is the treatment group for T. When the drug was successful, the number of the patient that recovered from the condition were counted, and the number of the individual did not recover were also counted. So here we have data for a treatment group for those who successfully recovered and those who failed to recover. The second section here is for the control group, in which the individual who were successfully recovered from the condition without the treatment were counted, and those who did not recover and failed to recover from the condition were also recorded. So here we have two groups, and we want to compare the effect of the drug on the recovery of the condition. So we are looking at association between the taking the drug and recovery from the disease. And since the outcome here is binary or binomial, whether successful or failure, so either yes or no, so whether successful or failure, so this is a nominal outcome, and it has only two levels in it, successful or failure. To find out the association, then an odds ratio will be calculated, and to perform meta-analysis for these 12 studies, comparing them and pooling them and summarizing the result from these 12 studies to reach eventually a conclusion whether there is an effect of taking the drug on treating the condition, then meta-analysis will give the pooled effect size based on the odds ratio. To perform the meta-analysis, in the section here for the Stata, click on statistics, scroll down to the option which is for meta-analysis, click on it, a new window will appear which shows here the meta-analysis control panel window. There are several sections for the meta-analysis method, and these section need to be filled. Setup section, summary, forest plot, heterogeneity, regression, publication, bias, and multivariate. So we're going to select and fill some of these, as the focus will be on generating forest plot and funnel plot. The first step is to declare that the data we have is a meta-analysis data. And since we are computing a binary outcome, then click on compute and declare effect size or sizes for two groups comparing or comparisons of a binary outcome. So we have here a binary outcomes that have two levels in it, or dichotomous outcome. So once this is selected, scroll down here, and in the main section, enter the variables for, first of all, the specified group 1 and group 2 as shown here. The groups are sectioned and labeled as treatment variable, control variable. So the number of success, tick on that and then select for success, and the number of failure for the treatment, select the treatment failure, and for the second group, which is the control, select the C for control success and C for failure for number of failure. And to specify which effect size to use, there are several options whether to go for odds ratio or risk ratio or risk differences or logo Pareto's odds ratio. So stick to the log odds ratio, and then to declare the data, click on submit, and as shown here, the data is identified as for meta-analysis to perform the meta-analysis, and a 95% confidence interval will be generated, and a random effect model will be selected, and the method selected is the REML. Once the form is submitted, we could also go back again and modify setting if we want. For the model here, we could select the random effects or fixed effects. We'll stick to the random effects, and then the models we could use is as shown here. There are several options. If we are interested in the fixed model, then the Mantel Hansel's method can be used, but let's stick to the random effects, and we've already submitted that. Moving to the second section here, which is the summary. Again, another window will appear, and as we said here, summarize meta-analysis data. We've selected the random effect. We stick to the restricted maximum likelihood. We could click on RE options. We are not going to do sensitivity test. We stick with the basic here. Since we are not interested in doing subgroup meta-analysis, this is a section if there will be a subgroup meta-analysis. If we take on options for the confidence interval 95, report effect size, we say report just the effect size without exponentiated. We stick with that. So let's click here to report a t-test and z-test for overall effect size. And let's take and see what is in the display options for setting up the coefficient decimal format. None of interest. Then if we click also in maximization, no options will be selected. Once we have filled this form, click on submit to submit the conditions or criteria. And as shown here, a table is generated for the meta-analysis summary and shows that from study 1 to study 12, the odds ratio is generated for each study with 95% confidence interval and percent of weight. The weights reflect here impact of the sample size on the analysis. And as shown here, a probability value is given, and Q value is given, and also for test of homogeneity for Q value and a P value. Continue with filling the forms here or the sections. If we tick on the forest plot and then select the random effect, keep everything as it is. If we click on options here, again there are certain options here to select from. We could also report t-test instead of z-test for the overall effect size. In fact, I'm going to stick with the z-test, so I'm going back again to the summary and untick this and then submit that again. So we have here similarity in both selection. And for maximization, no changes. For forest plot, few changes here. For options to change the confidence interval bracket, whether bracket or parentheses or none. I'm going to do a few modification on the plot. I'm going to select draw the overall effect size line, and by giving this also clicking on line options and giving it a color of let's say blue, and if we find here the blue, and then pattern, let's say the pattern is dash, and then click on accept. For the no effect line drawing, click on options and line options, and then let's give it a red color, and then default let's make it a pattern for dash, and then accept, and then okay, and then okay again, and ignoring the rest here. And for test options, no changes here, and for two-way options, no changes here. So now we are ready to submit the form. If we click on submit, a diagram is generated, which is the forest plot. So the forest plot here has three sections: the descriptive statistics, the diagram here, and the overall statistical analysis. And as shown here on the left hand side, the study ID from 1 to 12, and descriptive statistics for the intervention and the control, and the number of those who were cured and not cured, as shown here. On the right hand section, the odds ratio is calculated and given here for each individual studies, from study number 1 and to study number 12, and then 95% confidence interval is given, also calculated and assigned next to the odds ratio, and the percentage weight for each individual study is given here, that should all adds up to 100%. And as shown here, the overall odds ratio is given, which is 2.79 with a confidence interval. The next section in the graph is the symbols here, that each one of them represent each study. The small square represent, blue small square represent the estimated effect size, with in this case, which is the odds ratio. So the odds ratio for the first study is given in a square here, and it's 3.8. So it's around here, 3.8, around this area here. And the horizontal line represent the limits for the 95% confidence interval for the upper and lower limits. And as shown here, the size of the square, or the estimate size, effect size or effect size, is variable, or the sizes are variable. So some squares are larger and some squares are smaller. The size of the square reflects the weight percentage. So higher number of participants will have a larger square. The blue vertical line is the line representing the overall or the pooled odds ratio, which is 2.79. And the red dashed line is the line of no effect, and as shown here, there is a ruler or a scale for the odds ratio. Moving to the third section in the forest plot, shows the overall test for homogeneity and overall effect size. For homogeneity test, tau squared is generated. We will stick to the I squared value, which is equal to 12.1%, which shows low level of heterogeneity, and p-value of less than 0.05 will make it more heterogeneous, but here, since the value for the p-value is greater than 0.05, so this will indicate that there is a low level of heterogeneity. So for low level of heterogeneity, the p-value should be higher. So this meta-analysis showed that there is low level of heterogeneity, for which is around 12%, and a p-value of 0.4. For the overall effect size, which is the overall odds ratio calculated here, which is 2.79, this odd ratio is significant, statistically significant, as the p-value is less than 0.05. And from that meta-analysis, it is fairly could suggest that the analysis would suggest that intervention by using this drug have an impact and an effect, and it can improve the recovery from the condition, as the odds ratio for those who were treated is 2.79 times more than those who were not treated. So the drug is effective. So that is the essence of performing meta-analysis on these 12 studies to finally reach a conclusion that they all looks like they are all agreeing that there is an influence of taking the drug, or the drug is associated with the recovery. This is the way to analyze the forest plot. Back again to the forms here for meta-analysis. We've already submitted that and we draw the things. Let's move to the section for heterogeneity. Again, select the random effects, and there will be no much changes here. Just click on submit. A graph is generated, which is the Galbraith plot. Will not describe it here. We'll move to regression. No major selection of regression at this stage to do. The most important thing is to look at publication bias. And the way to look at publication bias is to draw funnel plot, or do another regression which is called Eagers regression. What are we going to look for? Publication bias, funnel plot for graphical diagnosis of a small study, test for small study effect in meta-analysis. We'll stick with the funnel plot, and the main thing is a standard funnel plot, nothing in FN, and model. Select the random model. Options, as shown here, we could specify the y-axis metrics using standard error, inverse of standard error, variance, inverse of variance, sample size, or inverse of sample size. Stick with the standard error. And there are certain things here we can select: produce separate plot, pie group, suppress meta setting information, not of interest. Let's go and tick on submit, and a funnel plot graph is generated as shown here. On the y-axis, standard error is given, and on the x-axis is the effect size, which is the odds ratio for each individual study, and these dots represent each individual studies. The plot here is in the shape of a funnel, inverted funnel, and the red line is the overall effect size, or pooled effect size, which is 2.79, and the dot, as I explained, each one of these dots is the estimate size for each individual study. For no presence of publication bias, the distribution of the estimate effect size on both sides of the funnel should be equal. So here there are 1, 2, 3, 4, 5, 6, 7 above the estimate effect size and 5 below. So here there in this plot indicate that there is a certain bias in the publication and further test ought to be done. So this is the way to do meta-analysis in Stata when the outcome is binary and the effect size used is the odd ratio. Two plots can be generated, or plots, the funnel plot and the forest plot.